web cracking, how to bypass captive portal authentications, so that can be pretty cool and interesting, and then attacking station associated to given networks. So management traffic is supposed to keep the state of the distribution system, so what we call the DSS, keep the state okay. So managing association mainly, but so few things. Thing is, management traffic is totally unprotected. It's clear, it's not authenticated, you don't have integrity check on it, so you just can play with it as you like, especially spoofing management traffic. So, because management traffic is responsible to keep association, it's really easy to put denial of services on a wireless network. So you can just reject association request, station want to get associate, and you just answer faster than the access point. For people who are already associated, you can send disassociation frames, so telling them, oh, I'm the access point and I don't want you anymore on my access point, so go away, and they go away. You can inject fake association, so that's for APs that have a limited number of association at the same time, so when it's full, you won't connect anymore. Well, for laptops and things like PDAs, you can send frames to wake them up. So tell them, oh, wake up, I want to talk to you. And then you have a simple and cheap battery depletion on the device. So playing with management traffic is mainly things of dynamic service. Management traffic generation is very easy. Any driver able to do master mode, so to be used as an AP, is able to inject management traffic. So for my test, I played with Scapy. Scapy is a Python generation, Python network traffic generation tool. So it has a pretty good Wi-Fi layer stuff, so you can just have a look at it and have a look at nifty packet classes that are already built. So you can just make denial of services with one Python one-liner. So you can see .11 packet is association, association answer, reassociation answer, deauthentication, etc. Rogue APs. So basically, if you want to build an AP from a usual Wi-Fi adapter, then you indeed need to inject frames. So you need to inject mainly traffic management. So you need to inject beacon frames. So other station can see you as an AP. Beacon frames, answer probe requests, if you want to answer them. Association requests, so you have to answer association requests so people can get association. Generate management traffic, and generate hacks from frames that are exchanged on the same wireless network. So if two associated stations want to send frames between them, then the IAP will get the frames and then duplicate them. So you have just one flag in the frame that is changing. It's 2DS from DS frame. So stations are sending 2DS frames. So I'm sending a frame to the distribution system, and then the AP has to take the frame and copy it again, setting the from distribution system to the other station. So you have to implement this. So basically, if you're able to build an access point, you can go to any wireless network and just play the access point and just try to get people associated to your access point instead of legitimate access point. That's what we call rogue APs. So rogue APs is quite a cheap attack. In fact, you just only need a wireless adapter and a IWW config by interface mod master, and then you're an AP. Recently, there was a lot of work against Wi-Fi network managers. So if you have Windows XP or Macintosh, you have just a little program that allows you to choose which wireless network you want to connect to, and it can be set and is set by default to an automatic choice. So there's been a lot of work, so you can go to see this website. It's quite interesting with a tool called Karma, which is just a tool to listen to prop requests, so see to which AP people want to connect and then fake them on the fly. So that's quite efficient, that's very easy to set up, and once people are connected to you, then you can just play with that traffic the way you want. So web cracking. So it's been quite a long time that we know that web can be cracked, but if you can't inject traffic, you just have to wait to gather big amounts of frames. So it takes, depending on the network, it can take from 1 or 2 hours to a few days or a few weeks. So web is RC4 based. So RC4 is used for SSL, for example, so quite a good stream cipher, but in the Wi-Fi context is totally inappropriate. So RC4 is XOR based. So XOR is some kind of magic computing operation. You can do about anything about it. So in the Wi-Fi context, it's prone to several attacks. So the first one is a clear text attack on the authentication mechanism. So basically, the guys who have invented this, so they said, I want to authenticate someone, so I want to verify as a good key, but I don't want to exchange the key of the network. Okay, so we use challenge response mechanism. So basically, they send a challenge, which is 128 bytes, not bits, bytes, which is quite long and is quite important for the following. So they send the challenge, and then the station encrypts the challenge and send it back on the wire. So if the AP can decrypt it, then the guy has a good key and is authenticated. But the thing is, RC4 is vulnerable of clear text attacks. So if you have the clear text and the cipher text, then you can grab the key. And that's it. So if you use a web network with authentication, then you're vulnerable. This leads to what we call PRGA highly coupled attack construction. So the thing is, the key changes for each packet, because each packet uses a different initialization vector. So the key used to cipher the packet is a 24-byte initialization vector plus a fixed key, which is 104 bits or 40 bits, depending on the strength of the cipher. But using clear text attack, you can just build a relationship between the RC4 output for a given IV, and then make a table which, in the end, will allow you to decrypt any packet on the network. So the size of this table is about 20 gigs, which is, I mean, any laptop on the market has this amount of storage.